Hi, and welcome everybody to this presentation of our paper entitled Can Microservice-Based Online Retailer Be Used as an SPL? This is a paper that's published as the SPLC 2020 conference in the challenge track. So the work in this paper was conducted by Benjamin Bény, Jean-Philippe Kessy, Sébastien Mosser, so myself, and Jan Ganel Guéhenuk from Concordia University and UQAM. We merge our team effort in this work to really address the variability issue in microservices engineering and microservices architecture. So to deep dive quite quickly in the context of the work, we are working with 6 reference architectures that were identified in the challenge we are answering. And so the 6 reference architecture implements 6 different microservices architecture. One is Hipster Shop, Stock Shop, eShop on Container, and the commonality of those 6 services are that they are all implementing e-shops, so online retailer, and they're very different. There's a lot of variability inside those different architecture in terms of technologies, in terms of size, in terms of features. It's like really interesting to look at those. So inside those 6 curated architectures, the author of the challenge were asking like several questions, and we can summarize those questions into a single one, which is, can we use such e-shops as software product lines? Is it possible, for example, to consider that in an e-shop you have a user management, a basket management, and an order management services provided in the architecture? And would you be able to switch from one basket management service to another one? That's the kind of question we were asking ourselves when we were reading the challenge description. So more specifically, we first tried to address challenge number 4 in the challenge description, which is, can you propose a solution to interchange microservice of different technologies within a system? But by deep diving inside those this problem, and by drilling like more specifically into how to do that at a concrete point of view, from a technological point of view, we realize that being able to interchange means for sure feature compatibility. You're not going to replace basket management by credit card payment. It's totally different things. But it also requires communication compatibility, technological compatibility, and very important for services, loose coupling. So it's drove us to the first challenge actually described in the description, which is, can you identify the features and like establish a mapping and compare the different systems together? Because then to be able to interchange stuff from one system to another one, you have to be able to understand the kind of features you're talking to. The main problem in this context, and in the context of microservice architectures, is that there's a lot of technologies involved, like a lot. And actually, it's very intrinsic of the microservice paradigm, which is develop small and independent microservices that are isolated from each other and that can be developed according to any technology, because they will be containerized in the end for a deployment level, for example. So the 6 reference architectures involved a lot of different languages, a lot of different deployment technologies, a lot of different database technologies. So it's from a source code point of view, it's quite a mess to handle all those different like technological choices involved. So the methodology we applied in this context of those 6 reference architecture with a lot of technological variability were first to work at the feature level, so identify the different features and how they map to services. So this was done at a core train level, and this was a manual process, like because we did that manually. Then we used a tool called an Anaximander to help us refine this coarse-grained mapping into a more fine-grained mapping, like more associated to code artifacts. And here the challenge is to handle the technological variability. Then we tried, because if you want to interchange one service by another one, you need to identify the dependencies of those services. So we used semi-automated tools to support the identification of a call graph among the services to characterize their coupling with the others. And we also digged into the Git commit history when we had access to it to identify the code development, because even if two services are not are supposed to be isolated, well, if each time you commit in one service, you are modifying the other one, it means that they're not that independent. And here again, the challenge was to handle diversity in this context. In front of such variability, the approach we are taking is an approach that is following the good enough paradigm. Instead, we are not aiming to obtain the best and ultimate representation of what happens inside the microservice architectures, because too much database, too much deployment technologies, too much languages, and really too much details inside, too much heterogeneous details. So we are using a more good enough approach, stating that, okay, we're going to build a partial map, for example, a manual one at the beginning, and then we're going to add some details inside the map, our comprehension of the system. So this is the idea of the Anaximander tool suite that we are developing in the team. And the idea of how you can use this tool is really that you have some probes that are defined as isolated software system that can help you to work with specific technologies. And you can run the probe inside the microservice architecture to obtain like a partial view of the architecture with respect to that probe. And then you can compose this partial map with a pre-existing one if you had one, and that it gives you your call graph, for example, or your analysis of dependencies and this kind of things. So the tool is open source, and you can check in the video description if you want to get to the tool. So how does it work? Well, you will use a probe to analyze source code or execution trace, and it will give you some partial view of the system, and then you can run another probe to get another partial view of the system. And then we use graph composition algorithm to identify it's basically a match and merge approach, stating that, okay, those two services are the same, those two routes are the same, and those one too. So it brings us to this global version of the microservice architecture where this service is connected to this service because they are like connected by a call. So the results we obtain, first I must state that those are preliminary results because it's really like we're starting something on working on microservice architectures from a software product line point of view. It's kind of like an open world that we still have to explore. So we first started to do the feature mapping. So this was, as I said, semi-manual process. We started first to go through the services by hand, and then we started to categorize each in each system. So those are system 1, 2, 3, 4, 5, 6, and this is a service stating about payment, which kind of features were provided by the system. All the results are inside the paper and on a companion web page where you can go into all the detail if you want. In terms of the call graph, we use first the manual identification of the different interesting routes, and then we can use stuff like an Anaximander to build the global call graph. And what the kind of information we obtain from this was that measuring the coupling is very technology dependent, because the way you communicate with service can be like direct, so it's very strongly coupled, or can be more indirect through message queue or this kind of asynchronous communication paradigm. And we also discovered that you can hide coupling. Like if you took a theoretical approach by measuring the coupling at the external HTTP connection, for example, it will not work because coupling can be done by sharing databases or sharing like data objects at the data access layer. So it's really more complex than just stating that, okay, this service is connected to the other service. And finally, the co-development was quite interesting. This is a figure representing for each service. Each time you commit to this service, you also commit to this one and this one and this one and this one. So it's kind of low, except for some services that in this case, each time you commit to checkout, there's a lot of commits involving checkout, product catalog, and shipping at the very same time, meaning that those services might not be that independent. To conclude, as I stated, it's a preliminary study, so the results are really like first step in the direction of identifying variability and how we can apply variability techniques in the software in microservices ecosystem. And clearly interchanging one service by another one, it's just not replacing one service by another one in the code. It's way more complex. From if we take a step back from a researcher point of view, the variability and diversity that exist in the microservice ecosystems is amazing, and it's amazing in the good sense, like there's a lot of challenges to address here, and also in a bad sense because it's really, really frightening, and you have to be like you have to have a lot of expertise in very different technologies to just be able to understand the code. From the perspectives we are trying to address in the upcoming months, it's first from a distributed system point of view, measuring how services are coupled to create like metrics that can be useful, like really useful for developers, is one of the awesome perspective we're working on right now. And from a software product line point of view, we are working on really modeling the different facets of microservices. It's related to hexagonal architecture and those kind of things, but having like a variable way of representing those features. And also from a reverse engineering point of view, it's how we can automate as much as possible the extraction of variability models from such architectures. That's really what we are into it. And if you're interested to discuss about those topics, please just message us in the platform and we can just discuss about it. So thank you for attending this presentation. It was a pleasure to do this work, and you have here our contact information on the Concordia team or in the Yukon team. And I hope that you enjoyed attending this presentation, and I hope that you'll come and discuss with us. So see you guys, bye.